In this video, we'll see what is the default step-by-step method of the routes getting installed in the routing table, what is the default order of selection, and what it is going to see initially. So now, by default, let's take an example. I go to router 1. The router 1, I'm going to router 1 and then I'm configured a static route, and I say IP route, and I'm going to say 192.168.2 network, and the next hop address is this. Okay, so before the route getting installed, whatever the kind of routing you are using, it doesn't matter. So for any route, before it gets installed in the routing table, it must have the valid next hop. Now it is going to verify the next hop. If the next hop is reachable, in that case only the route will be installed in the routing table. So if the next hop is not reachable, in that case it is not going to install the route in the routing table. So the mandatory condition for the route getting installed in the routing table is you must have a valid next hop address, and that next hop has to be reachable. Now, assuming that the next hop is reachable, now in that case, let's say from the router 1 to reach 192.168.2 network, there are two possible routes, and maybe there are two routing configurations done. Now there are two possible routes here. Now in this case, first it will be going to see the longest match. Now whichever the route is having the longest match, that route is more preferable, and it's going to check the longest match here. Let's take an example. In my scenario, let's say from this route, the destination network ID is 192.168.2.0 and the subnet mask is /24, and whereas the alternate route here 192.168.2.0, 2.100, and the slash value is 27 or 28. Let's say 2.0 with a /27. Now here you are able to receive the same route here, but there is a different mask. In that case, it's going to prefer the longest match. So first it will see the longest match so that this route will be installed in the routing table here. Now in case if there is a tie in the longest match, then the next condition it will see the administrator distance. If the route is coming via static and the route is coming via RIP administrator distance is 120 and the static administrator distance is 1. It's going to install the routes based on the administrator distance, or it can be like two static routes you have configured like we did in the previous scenarios, floating static routes where you have the administrator distance of one static route, or the default route is 1 and the other one is 10. It's going to install the least administrator distance. So before it actually verifies the administrator distance, it will see the longest prefix match, and if the prefix match is same on both the sides, then the next condition it is going to verify the administrative distance. And then if the administrative distance is same, like let's say if both the routes are coming from RIP and RIP, in that case it is going to see the least metric, whichever the route is having the least hops. In case of RIP, like 2 hops, 3 hops, 2 is more preferable. It's going to install the routes based on the metric. And let's say if metric is same, in that case finally it is going to do something called load balancing. Now for basic verification, I got a router 1 here. On the router 1, if I verify show IP route static based on the same labs what we did in the previous floating static routes. Now to reach 192.168.1 network, there is a static route and that is going via 10.002. Now what I'm going to do is I'm going to configure one more route, static route, for the same 192.168.2 network, but this time I'm going to configure it as /27 subnet mask, and the next hop address I'm going to give 12.002, and also I'm giving the administrator distance of 10. Now here what I'm doing is that to reach 2. network, this is /24, this route, and the other route which I'm configuring is it is 2. network, the same network, but it's /27. Let's verify which route will be getting installed in the routing table. So if I go to router 1, if I verify the routing table, show IP route static, now I can see both the routes are getting installed in the routing table. Now I can see both the routes are installed in the routing table, but it's going to see the longest match, which means if it has any packet to send within this range of /27, it's going to forward via 12.002. Okay, so let's say there is a trace. If I just try to trace here to 192.168.2 /27, means it comes in the range of 0 to 31. If I'm tracing to something like 2.21, within that range it's going to 12.002. Okay, it's going by 12.002. But if any packets comes outside this range, Outside this range means slash 27 means here it will be 0 to 31, and anything outside this range, if I try to trace 192.168.2.100, it's something outside the range, so it's forwards based on this. So the first thing, it will see the longest prefix match, and in case if the prefix is same, in that case it is going to consider the administrator distance as the deciding factor. Like in the previous scenario, we discussed that we have configured some administrator distance for the static route here is 1, and via this route we have configured 10. It's going to install the route with the administrator distance value of 1 because it is same. But in case if both the administrator distances are same, in that case it will see the metric. In case of static routing, there is no metric, but if you're using RIP protocol, in that case it will see from this route to reach here there are 2 hops, and from here it is just 1 hop. It will decide the best route based on the hop counts in case of RIP. In case of EHRP or OSPF protocols, it will see the least cost. And if both the routes have the same metric, then in that case it will install both the routes and forward the traffic via both the routes. And that is what we call as equal cost load balancing. Now this is a default path selection process, or the default step-by-step process which is considered by the routers when they install the routes in the routing table.